Okay, so we start with question 1. So question 1 is you have to define two matrices, okay, A and B. And now let me share you my MATLAB screen, okay. So I stop. So I assume that you have the problems in front of you, yes? So now I share the screen of MATLAB. Okay, so you see the screen here, yeah? And now I make a new script. So I make a new script. So I click on this new script. Okay. So now the problem is now you don't see my new script. So I have to share the whole screen. Oh. Okay, so you can see my screen, yeah? So you see there's two windows. The windows, the editor's windows, and the commands windows, okay? And now I start typing. So question number 1. So question 1, part I, yeah. So now I define the matrix A. So the matrix A will be 100 by 200. So this commands ones, you know, like ones and two numbers. So it gives you a way to define the matrix of size 100 by 200, and all of elements are ones. Okay, so there's some related commands. So related commands is like zeros. So if you have A equals zeros, okay, 100, 200. So you can guess that, you know, this command will give you, you know, a matrix of all the zeros of the size 100 by 200, okay? Or you can have identity matrix. So if you have a identity matrix of the size, say 100, okay? I for identity. So you can check. So suppose I put in A, so you see my command windows, yeah? So A zeros, so just take a small number, say 2 and 3. You see that is a 2 by 3 matrix, and all of them are zeros. Or you put in ones, okay? Then you see all the elements are ones, yeah? Or you put in I, say 3, so identity matrix, okay? 3 by 3 identity matrix. So that is how you define the matrix A. So how, now with the matrix A, how do you define the matrix B? So any suggestion, and then any ideas? So suppose now I have the matrix A already. So the matrix B, yeah, so somebody say something here. Yes, B is just equal 1 plus 1, yes, or it can be 2 times A, okay? So either way, but you know, you can see that directly from the matrix A, yeah? So where is my editor? So my, oh, sorry. So my editor is here. And now I can put in B equal 2 times A, okay? And now let me run it first, yeah? So when I hit the green button, then it asks me to save as a script files, you know? So I save maybe week 1, and then save it, and then it will run. So you see that, you see now when I run it, then it has matrix A. So all of them are ones, you know, so big, so you cannot see it on the screen. and B. Okay, but you get the ideas, yeah. And now, how do I do the next question? So the next question is the matrix C. So how do I define the matrix C according to the question? So any ideas? So what is the pattern? First, what is the pattern? Can you say what is the pattern for the matrix C? What is the pattern for the matrix C? You can put in the chat box. Anyone? Well, okay, so what is the pattern for the first row of the matrix C? What is the pattern for the first row of the matrix C? Anyone? Are you still there, or all of you are still there? So what is the pattern for the first row of the matrix C? Are you still paying attention, or are you watching TVs? So what is the pattern?
People are typing answers into the chat. I just don't think you can hear them.
Yeah, you can type the question to the chat. So let's see whether I can see it. So
这东西不能穿墙吗？可以。
I don't see anything in the chat box. So well, but you can say it because, you know, I mean, not many people here. So how many people we have? We have only 37 people. So not so many. So what is the pattern? Somebody say something. You can unmute yourself. So
increases by 1.
yeah, just increase by 1. Yeah, so just a consequence. I mean, just a consecutive sequence. Okay, start from 1 to 60. Yeah, so row 1 is, you know, like start from 1, increase by 1, and stop at 60. Okay, so this one is the construction of MATLAB. So start, then it increments, and then it ends. So you see, like when in MATLAB, if you type in a construction like this, so 1 increased by 1 and ends at 5, for example, then you see that you have a vector start from 1, increase by 1, and then ends at 5. Okay, so when it increased by 2, you can say that if you increase by 2, you stop at 10, for example, and you got 1, 3, 5, 7, and 9. So it will stop before it hit the stopping point. Okay, but and if you increase by 1, you don't have to put in the increment. So you can say 1:5. Okay, or 1, say 10. Yeah, so you see that is exactly what I'm going to use here. Okay, so the row 1, just start from 1, increase by 1, stop at 60. Okay, and now row 2 will be start from 119. Yeah, and now it increased by -2. See, so it increased by -2 means that decreased by 2. Then it stop at 1. Okay, then row 3 will be -3. Yeah, so start from -3, increase by 3, and stop at 174. Okay, so then you have 3 rows, yeah, and then now you just stack row 1 on tops of row 2 on tops of row 3, and that's it. So you run it. So if you hit the run button, you will see that C will be the matrix C will be, start from 1, 2, 3, 4, 5, 119, 117, 115, and the next row is minus 3, 0, 3, 6, and so on. Okay, so that is how you define the matrix C. Okay, so now how about the matrix D? So anyone tell me what is the what is the pattern for the matrix D? So what is the pattern for the matrix D? You can unmute and say something, or you can put in the chat box.
It seems like it changes the order of the columns of matrix C.
Exactly. So what you are saying is correct. So the first 4 columns of the matrix D is just a permutation of 4 columns of matrix C. Okay. So we will do exactly like that. So we say that, okay, the first columns, yeah, of the matrix D is just the 3rd column of the matrix C. Okay. And in order to extract the 3rd column of matrix C, then you type in a command like this. So what does it mean here? So this one just means that the column is mean that you take all the rows, yeah, and here the column is 3. Right? So you can type in MATLAB and see exactly how it works, yeah. So suppose I put in my command windows C, yeah, colon, and then 3, and you see that it gives you the 3rd column of the matrix of the matrix C, yeah, and then the 4th column, so C4 is C colon and then 4, and you do the same to get C1 and C2 equals C2. Okay, so this one is the 3rd column of matrix C. Okay, and now you just construct the matrix D by the 4th columns, or maybe sorry, should be the 3rd columns, yeah, the 4th columns, and then the 1st columns and the 2nd column, and the remainder is just on the rows, yeah, but now the columns run from column number 5 to the end. Okay, so this one just means that you take the submatrix C, take on the rows, but the columns run from column number 5 to the end, to the last columns. Okay, so then this one gives you the matrix D, and you can run it. And you run it, and you will see that the matrix D will be like this. Okay, so you just type in the commands, yeah. And now, how do you define the matrix X? So how do you define the vector X?
is the power of the 2 from 0 to, I think it's 12.
13. I think 2 to the 13 is 8,192. So yeah, so the power, okay, but now how do we define it? So you see the pattern, yeah? But how do we define it? How do we define the row vector x? And someone put in the chat box. My chat box seems not working. So yeah, okay. So somebody put it in here, yeah. So almost correct. I think you don't need the square bracket in the beginning and the end. Okay, so we will define exactly like this, but we don't need the square bracket in the beginning and the end. So if I put it in, I will show you. So I will put like this, yeah. So x will be 2 to the power from 0 to 13, okay? And remember the dot here, it just means that it takes each element of the vector, okay? So 2 raised to the power, and the power is the element of the vector from 0 to 13, okay? So when we run it, then you can see that the vector x is exactly what you expected, okay? And now what is the next question? So the next question is how do you define the vector y?
-2.
Yeah, so just -2 raised to the power, right? So we take -2 raised to the power. So y is -2 raised to the power 0 to 13. Okay, so that is question 1. So okay, so we have to run it and see it's correct or not. So if you run it, you will see that so you see that the vector y is correct, yeah? So 1 minus 2, 4 minus 8, and so on. Okay, so now what about the next question? So the next question is, how do you solve the linear system? So how do you solve the linear system? So the linear system, remember the linear system is the coefficient, and then there is x1, x2, x3, x4. Okay, so how do we solve it? By MATLAB? Well, in MATLAB, it's very simple. Now you just put in, right, so back the previous, somebody said that y is x to the -1. Yes, it's still correct, but I think, yes, it's correct, but -2 seem to be similar, right? I mean, yes, you can do, so there's many ways, yeah? Okay, so now go to the question 2, right? So now we started question 2. So let me go to question 2. So question 2 is solving the linear system, yeah? So now let me define the matrix A. And the matrix A is exactly like given in the in the problem. So and 3 minus 5 to 0 and 2 2 minus 1 minus 4. Okay, and now the coefficient, the right hand side is just a column vector. So 11, 17, minus 14, and 2. Okay, and now you just take x to be a backslash b. So this one just means the solving ax equal b. Okay, so you see the backslash command is very powerful. And if you know C or Java, you will know that solving a linear system is not easy. You have to use a lot of library functions, and it's not straightforward. But in MATLAB, because it's designed for manipulating matrices and vectors, so solving a linear system is just very straightforward for MATLAB. So somebody say, done too much trick that had my brain. Okay, so no problem. Okay, so now we have the linear system, right? So we solve it. So this is so this one is part I, yeah. And now form the matrix, form the symmetric matrix B. Okay. So B is A transpose A. Okay. So there is a remark here. So A transpose, when you put a prime like this, actually take a transpose and a conjugate as well. Okay, but because we are real matrix, so we don't have to worry. So I can show you what I mean by this. So if I go to MATLAB and suppose I have a very simple vector. So suppose x is 1, 2, right? A row vectors. So when I take x transpose, I get a column vectors, 1, 2, no problem. But when I have x is 1 plus I, remember MATLAB, taking complex numbers, 1 plus I and then 2. So when I take x transpose, x prime, then I got 1 minus I, okay, and 2, yeah? So we have to be careful, okay? So the prime, take the conjugate and then transpose, yeah? So if we want only transpose, then you have to put in transpose the full command like this, then everything is okay. So make sure that we know what we are doing. But in our case, because the matrix is a real matrix, so we don't have to worry a lot. We just take A prime times A, yeah. And now eigenfunction and eigenvectors. So remember, what is an eigenvectors? Anyone remember what is the eigenvectors, eigenvalues? Anyone remember? So roughly speaking, what is the eigenvalues? Yes, the formula is correct. AV equal lambda V, yeah. So essentially, like suppose you understand A is a linear transformation, right? So when you apply linear transformation to a vector, then you get another vectors, yeah. But if after you apply the linear transformation, the vector doesn't change the direction, it's just expanding or contracting, then we call it the eigenvectors. And the coefficient that either expanding or contracting, we call it the eigenvalues. Okay, so finding eigenvalues and eigenvectors are not easy, right? So if you remember first year linear algebra, you have to solve characteristic polynomial to get the values, and then from that you have to take a null space in order to get the eigenvectors. But in MATLAB, they they have done it for you. So you just put in v comma d equal eig of b. Then the matrix V will contain the eigenvectors, and the matrix D, it's a diagonal matrix, will contain the eigenvalues for you. So you run it, and you will see that in the command windows. So now V, you see, so it will be 4 eigenvectors, and D, a diagonal matrix that contain all the eigenvalues. So if you give 2 output parameters, V and D, then it gives you the eigenvectors and the eigenvalues. But if you want only the eigenvalues, you just put in only one output parameters. Then it gives you a vector that contain all the eigenvalues. You see, so 1.2065, 18 point something, 40 point something. You see, so a list of 4 eigenvalues. Yeah. So that our next question is, how do you verify the answers? How do you verify the answers? So how do you know that what you are doing is correct? Or how do you know that MATLAB gives you the correct answer? So go back to I. I is you solve Ix equal B. How do you know that MATLAB gives you the correct X? So how do you know it? Phi Ix, yes, and then make sure it's B. Yes, that's correct. So essentially, I'm going to do exactly what you said, but I'm going to define a variable called errors. Yeah, so errors will be um, my errors will be Ix minus B. Yeah, so this one is very fine. So part 3. Yeah, so I say that errors will be Ax minus B, and I expect that errors will be close to a 0 vectors. Yeah, so I run it, and you can see that errors is not exactly 0, but it's very close to 0. Okay, so 1e minus 14 is 10 to the minus 14. And because you see in MATLAB or in chapter 2, you will see that, everything is approximate to a certain tolerance. You cannot have exact 0 inside computer. So 10 to the minus 14 is a very good, very close to 0 already. Yeah. So the errors is a vector that close to 0. So Ax almost equal B. Yeah. And if you just type Ax and you type B, and you see that they are very close. Okay, so the 4, 11, 17 minus 14 and 2. Yeah. And now how do we verify the next part, the eigenvectors part? So this is you verify the linear system. Yeah, so verifying solution of the linear system. Now, how do you verify the eigenvalues, eigenvectors part? How do you verify that MATLAB did the right thing?
We take A times V minus lambda times V.
Yes, okay. So first we have to take out the eigenvectors first, yeah? So V1 will be the first column of the matrix V, yeah? So this is my first eigenvectors. Okay, and then my lambda 1 will be diagonal matrix but the very first entry is D11, yeah. Then I take, remember the eigenvectors is from the matrix B. So we have to take B minus, B V1 minus lambda 1 times V1, okay? And this one is, maybe we call it error 1. And you run it, you will see that error 1, oh, something wrong here. Something wrong here, error 1 is so big. So what, what went wrong? So V1
it's not minus lambda.
minus, okay, so it become a
Yeah, it's positive.
okay, so, but now, okay, so now it's correct, yeah? So the errors is 10 to the minus 14. So 1 e to the minus, e minus 14, just maintain to the minus 14, yeah? And very close to 0, okay? So that's verified. So you can do the same for other eigenvectors. Now find the eigenvalues of A. Verify their product equals the determinant of A. So now I go back to find the eigenvalues of A. Okay, so now find the eigenvalues. Oh, so find the eigenvalues. So remember, eigenvalues of A can be found by this command, yeah? So you just give EIG of the matrix A, and when you give only one output, then it just gives you a vectors of the eigenvalues. So if we run it, so you will see that the eigenvalue of A is just those 4 numbers, okay? And now we know from linear algebra, okay? So if you are taking the math linear algebra, so math 2501, or 2501 or 2601, then there's a theorem say that the product of the eigenvalues will equal the determinant of the matrix A. Okay, so we will check that. So now let me check that. So now if I check, so I compute the product of the eigenvalue of A. Okay, so maybe I call it P1. Yeah. So this is a product. So this command just compute the products of all the elements and the vectors. Okay, so products of eigenvalues of A. And then D1 will be the determinant of the matrix A. So this one is another command, give you the determinant. You see that MATLAB has provided a lot of useful commands, for vectors and matrices. So it saves you a lot of effort. Suppose you try to implement it then from scratch, then it takes a lot of effort, yeah. So now we run it and we see that P1 is 304 and D1 is 304. So they are the same. Okay. So that's verify the theorem, at least for this case, numerically. Yeah, so any question so far? Any question? So far, so good, yeah? On good, yeah? Okay, so you see, you should play around with MATLAB, put in those commands and play around and you get the feeling for that. So if you've seen it before, and it's okay, but if you haven't seen it, then it's very good. way to get used to MATLAB. Yeah. And so now the next question is write a script to build an upper triangular matrix of dimension 12 having 4 on the main diagonals and minus 2 on the upper diagonal. Okay, so let me read it. So the matrix will be 4 on the main diagonals and minus 2 on upper diagonal. So there is a command in MATLAB. So if you go to the command windows, there's a command called diagonal like this. Okay, so maybe you can type help diagonal. You can read it, but essentially, suppose I have a matrix. A is diagonal of 1, 2, 3. Okay, then it just take that vector, okay, whatever the length is, and it put on the diagonal entries. Yeah, and now suppose I have the same vectors, but I want to put it on the upper diagonal entries. I just put in +1 here, and you see that the diagonals here, it's just a zeros, and it put the 1, 2, 3 in the upper diagonals. Yeah, but only one position, over the main diagonal. So we use this command for the question. So the question say that they want to do dimension 12. Okay, so we go back to here. So this one is question 2. Okay, so now I say that, okay, so the first one will be I want a dimension 12. Yeah, and all of them having 4. Yeah, so 4 times 1, 1, 12. Yeah, so this one is the diagonal. Okay, and maybe this one is our the diagonal part. So you see this one just means that you take the vector once. Yeah, or from of the size 1 times 12. So it's a row vector of 12 number ones, and you multiply by 4, and you make a diagonal contains of those elements. Okay, so that's give you the first part of the matrix. Yeah, and then minus 2 on the upper diagonal. So the minus 2 on the upper diagonal. So the minus 2. So you see that minus 2 is just minus 2 multiplied by 1. And now remember, because it's upper diagonal, so you have 1 items left. Oh, sorry, 1 item less. Yeah, one entry less. So it's only 11. Okay, and it's upper diagonal, so it will be +1. Yeah, so diagonal. So now, so this is my matrix A. A. And you see that if I run this, yeah, then I get a matrix A exactly like this. So 4, 4, 4, 4, 4 in the diagonal, and minus 2 in the upper diagonal. Okay. So MATLAB gives you a lot of, like special commands to construct matrices and vectors. Okay. So you can use a for loop, but the for loop will take more time in MATLAB. Yeah. And now, how to build a matrix B from A? So that the second and the 10th column are interchanged. Okay, so you swap the second and the 10th columns of the matrix A. So second and the 10th, so how do we do that? So we will say that, okay, so the second, okay, so the second, so this is a second row, yeah, okay, and now this is the first row, yeah. Okay, the first row look like this, okay. So then the 10th row, sorry, the 10th and the second, so got interchange. So this one should be, you know, suppose you put in from A from 1 to 12, yeah. So then the second should get interchange with the 12, yeah. Sorry, the 10th. The second interchange with the 10th. So if you, so this one should be the 10th, okay. And then this one is at the 10th column, yeah. So now what happened to the remainder part? Well, so this one you have to say that A, you know, so this one will be every row, and now it run from column number 3, yeah. So 1, 2, so 3, and it will end at column number 9, okay. And then this one will be your 10th column, yeah. And then you have 11 and 12. Okay, so this is how you define the B. So you just use the elements of the matrix A to construct the matrix B. Okay, so you see it. So now if I take the matrix B, you will see that the 10th is here. Yeah, the 10th column, let's swap with the second column. Right, you look at matrix A here, yeah, the second column, yeah, let's swap with the 10th column. Okay, so any question? Everything is okay, yeah. So now can you do the next question? So somebody answer the next question. So how do you do the matrix C? Can somebody just type in the commands and I put in MATLAB to see whether it's correct? Are you still there, or can somebody type in the commands? So yeah, I saw somebody type in the commands, yeah. So just type in and see whether it works or not. Just type it. Oh, no, sorry, wrong one. Okay, so now see whether it works, yeah. So C3 equal B3. Your B3 is this matrix, yeah. Okay, that's fine, yeah. Now let me run it, and now let me check your C3 and see whether it's correct, yeah. So the 4th and the 9th rows are interchanged. 4th and 9th rows are interchanged. One, two, three, four. the row, sorry, the fourth and the ninth row. So 1, 1, 2, 3, 4, yeah. So this is a fourth row, yeah. And this is the fourth row. Yeah, so that's correct, yeah. So the fourth row is the 9 rows, yeah. So you get the idea, right? So there's many ways to do it, but you get the idea. Okay, so the next question is sparse matrix. Okay, thank you. So now sparse matrix, just sparse matrix, you know, like in many applications, you know, like a matrix contain a lot of zeros. You know, suppose people try to model the flow through the wings of the aircraft, then they have to discretize, you know, the points on the wings, and they convert it into a partial differential equation, and then they convert it into a linear system, and the linear system has the matrix very sparse. You know, sparse means that it has a lot of zeros. So then in MATLAB, they allow you to do this. And why the sparse matrix are useful? Well, because you know sometimes the computer doesn't have enough memory, okay? Because you know, like in engineering application, you can have a billion by a billion matrix. It takes a lot of memory, yeah. And then it does not have enough memory, so then they save it as a sparse matrix. Okay, and sparse matrix in MATLAB, there's a command called sparse, and then you define sparse and 7 rows and 8 columns like this. Okay, and the sparse matrix they store only the non-zero entries. Okay, and the indexes. Yeah. So in this case, suppose I had sparse 7 rows, 8 columns, and then I have A12 equal 5. And then I have A37 equal minus 8. And A54 equal 12. So if you run it, okay, so if you run, so if I run it, you will see that you will see that the matrix A, you see, it doesn't give you the full matrix like before. It just gives you the index that contains the non-zero entries and the index of that non-zero entries. Yeah, and you can see that, you see, the whole matrix, there's 56 entries, but there's only 3 non-zero entries. So it's a waste if you try to store, no, sorry. Yeah, 56, yes, correct. If you try to store 56 entries, yeah. And the next question is, how do you write a script that creates the following tridiagonal matrix? Okay, so we have to make a new script, yeah. So new script. So suppose I make a new script. So I go to here, and I can click on here. So make a new script, yeah. So question 5. N will be input value of n. Okay, and then remember we use this. We have done this before in this question 3. So how do you adapt question 3 to solve question 5? So any ideas? So remember we've done. I can show you what I've done in question 3. Yeah. So actually, one is question So this is question 3. Yeah. So you see, that is how I define the diagonal matrix. Okay, so this one is define the diagonal matrix. You can create a sparse matrix with, but you know, you can use a diagonal command. Yeah. So, and actually there is a command called sparse diagonal. So if you can use this command, yeah, sparse diagonal. So I create a sparse diagonal. You see, so create a sparse and you know tri-diagonal matrix as well. Okay, so you don't have to do 2 steps. You can use this commands and you create, you know, like sparse diagonals, and it gives you the matrix straight away. So this is the, for example, this is how it works. Yeah. So anyone have tried this? So can you try this command? So this one create a tri-diagonal matrix. Yeah. And on the diagonal entries, it's just -2. And the upper diagonal entries, all of them are ones. And lower diagonal entries are ones. Yeah. So can anyone play with this command and show me how to do this? So you see there's a lot of example here. Yeah. So you can type it, these commands, you know, and see how it works. And so we use this command, sparse diagonals. So anyone? Well, okay, so suppose I type in this commands, you know, you will see how it works, yeah? So I type in this commands. Well, maybe here we have to say E is, well, we just cut and paste this into our script, okay? Because N is input right here, yeah? Okay, so now suppose I type in this command, yeah? So I save this, I run this. So I'm asking for the name. So I say week 1 question 5. Okay, so if I run it, so it will ask for n, yeah, so n equals say 4. Oh, yeah. So week 1 question 5 n equals 4. You see? So you see that the diagonals, it's just all of them are -2, right? So maybe I can show you the image of the matrix, and you will see that will be a bit nicer. Okay, so all of those blue one, yeah, are -2. Okay, and the yellow one are just 1, and the green one are 0. So the bar, you will see that that is exactly what is going on here. So the blue just -2, right? The greens are 0, the yellows are 1. Okay, and now if you look at the questions, You know, so you have 1, 2, 3 to the to the end in the diagonal. Yeah. So then we fix the diagonal first. Yeah. Okay. So now I'm going to fix my diagonal first. So, so diagonal will be, so if I say that this one is D0, yeah, and D0 is just 1 to n, okay? And then what is my off diagonal? So off diagonal is just -2, -3, up to -n, yeah? So maybe this one I call it the -1, yeah, is -2 and decrease by, I mean, increase by -1 and stop at -n. Yeah, so this one is my D -1. Yeah, and then the upper diagonals is n -1, go back to 2. So n, so D1 is n -1, go back to 2. And so this is my D1. Okay, so I just run it. So n equal 4. So we have something wrong. But the size of the matrix. So we have to check the size of the matrix. Yeah. So the diagonal, so it's correct from 1 to n, and the lower diagonal should be -2, and then stop at -n, and then D2 is n -1, stop at 2. Okay, so what is the problem? We don't need the vector E. Yeah? D0, something wrong with D0. So now if you write like this is still okay. Yeah? So the size of the matrix B. Okay, so what is dm1? dm1 is -2, -3, -4. Yeah. So what is D0? So D0 is 1, 2, 3, 4. Yeah. So it's correct. So what is D1? D1 is 4, 3, 2. Okay, so now I remember. So see, in the sparse diagonal, all the 3 vectors, you know, they have to have the same size. Yeah. So if you look at the example, all of them are the same size. Yeah. So you have E here, -2E, and E here. So we have to have the same size. So we can go back and we put in here is let make it -1. So let make it 1 here, okay, and see what happens with the same size. Yeah. No. Size of a matrix. So dm1, d0, and d1. Strange. It has to be a column vectors, not a row vectors. You see, if you look at the example, it should be the column vectors. Okay. So if we make it, we change it again. So if I make it the column vectors, I run it. Okay, so let's see whether it works now. Okay, so it works. You see. So sorry about that, but you know the vectors has to be a column vectors, and you can see that 1 and then 2 is 2, and then 3 is 3, and 4 is 4. Okay, and it start. So now 2 1 is minus 1. So maybe you want to start at minus 2. Yeah, so you go back to the editors and you say that, okay, I want to be from minus 2. Okay, and this one is okay. So now let me run it again. So n equal 4. And now, but it's not the same length. Okay, so we have, if it start from minus 2, then has to go to minus n minus 1. Okay, so now it's going to work, yeah. Okay, so start from minus 2, then minus 3, and so on. Okay, but you see, you just play around a little bit. Okay, and that's it. So any question? So maybe let me stop the recording first, and you can ask question. Yeah. So stop recording.